Last week, last class, we have class on Tuesday.
Yeah.
Okay, that means we have done the example using the conventional way, right? We did one. I showed one example in the class, right? So you know when to swap the rows for both methods, correct? Okay, so today I will continue to how to solve the linear system by using this LU decomposition. Okay, so first of all, you have to know this one. Okay, the linear system is actually AX equals to B. Okay, our system is AX equals to B. Since A is decomposed into LU, okay, A is LU, so we have LUX equals to B. But then we will let UX be Y. Okay, this UX, we will let it be Y. So we have LY equals to B. Okay, because of UX, we let it be Y. That's why this is Y. We have LY equals to B. Okay, LY equals to B from here, we will solve for Y. Okay, solve for Y. So your L will be something like this. Okay, we know what are the three values here. And we know the three values from the B. So what we want are this Y1, Y2, Y3. So forward substitution. Forward substitution means we will start from the first row. Okay, since this is Y1, Y2, Y3, that means this is Y1, Y2, Y3. So the first row, it means 1 Y1 equals to B, equals to B1, right? Then you know what is your Y1. Then from the second row, you have L21. Okay, that's means a known value. Okay, a known value Y1 plus Y2 equals to B2. Now, since you have known what is your Y1, then you can solve for your Y2. Then from the last row, you solve for your Y3. Okay, since we start from the first row, that means this is called as forward substitution. Okay, then we will get the values of Y1, Y2, Y3. Okay, from here, we know what are the values of Y1, Y2, Y3. Then we will go back to this UX equals to Y. Okay, so you know what is your U. You know the values of Y1, Y2, Y3. Now we solve for X. Okay, this is X1, this is X2, and X3. Okay, for this one, we will use backward substitution, where we start from the last row, we have U33, X3 equals to Y3. Okay, you know the values of U33 and Y3, so you can solve for your X3. Okay, when you know your X3, solve for your X2 from here. Then solve for your X1 from the first row. Okay, we start from the last row, so this is called as backward substitution. So at the end, we will find the values of X3, X2, X1, put them in a vector form. Okay, now I show you one example. Solve this by using LU decomposition. Okay, so this is the matrix form. Okay, this is the matrix form. And first of all, we will decompose the A into L and U first. Okay, I use the row reduction. So from here, by using two operations, we change this into 0. And coincidentally, this is 0. Okay, so this is actually this is same as this one. So this is your U. Okay, this is your U. To get an L, so we will take this 3. Okay, suppose you don't have to write this out. The 3 you can take from here. Okay, suppose the 3 you can take from here because this is already 0, so we don't need any operation to change this into 0 because this is already in 0. Okay, so this is your third pivot. Okay, so this one, the first pivot and the entries underneath all will be divided by 2. So you get this 1, 2, -1. Okay, then this is your second pivot. Okay, second pivot. These 2 divided by -2. So you get 1, 0. And your last pivot is 3. Okay, last pivot is 3. 3 divided by 3 itself, you get 1. So this is your L. Okay, this is your U. After decompose A into L and U, you need to write this out. AX equals to B. Okay, now, since A is LU, so we have LUX equals to B. Okay, then we will let, okay, we let UX be Y. Okay, let UX be Y. That's why this UX, maybe right in this form, we give a bracket. This UX, we let it be Y. That's why we have LY equals to B. Okay, so this is the L that you obtained just now. This is the B from the linear system. Okay, so this is Y1, Y2, Y3. Okay, we start from the first row. So Y1 equals to 2. You get Y1. Okay, 2Y1 plus Y2 equals to -1. You get this equation, but since you have already know your Y1 value, then you can solve for your Y2. Okay, and from the last row, this is -1Y1 plus 1Y3 equals to 1. Okay, and we substitute Y1. Okay, Y1 is 2, substitute Y1, then solve for Y3. Then you get your Y1, Y2, Y3 in a vector form. That's just by substitution. Okay, substitution. Then we back to the UX equals to Y. Okay, this is your U, the one that you decompose A just now. You get your U. And Y is what you obtain from here. Okay, this is your Y now. Okay, now we solve for X. So this is X1, X2, X3. Okay, but now we start from the last row, backward substitution. So 3X3 equals to 3. That's why X3 is 1. -2, X2 plus 1X3 equals to -5. Okay, get the equation first, then substitute the values that you have found, then solve for the X2. Okay, then the last row, the first row, 2X1 plus 3X2 minus X3 equals to 2. Write out the equation, substitute the 2 values that you have found just now, solve for X1. Okay, then you get the final solution. Just put it into a vector form. Okay, so see, if what you obtain from the L and U is wrong, that means your Y will be wrong, X will be wrong. Okay, so you need to compose the A into L and U carefully. Okay, this is another example. Okay, this one, when you put this into a matrix form, this is the one, okay, matrix form. So now we want to decompose this A into LU first. Okay, this A we decompose into LU. So draw reduce until you get an upper triangular matrix. That is your U. Okay, then find for your L. Okay, first pivot, second pivot, third pivot. Okay, then you get your L. So this is your L and U. Okay, next, start from this AX equals to B. You have to write this out. AX equals to B. Okay, then A is LU. That's why this is changed into LUX equals to B. Okay, and this one, we put a bracket for UX because we will let UX be Y. We let UX be Y. That's why you have LY equals to B here. Okay, so we will start from here. We solve for Y first. Okay, L, this is your L. B from the linear system just now. Okay, the linear system, this one, this is your B, 9, 8, 3. Okay, then forward, okay, forward substitution. Because we see this one, both are 0. Okay, this is the only non-zero, so we will start from the first row. Because y1 equals to 9, you get the value of y1 directly. Okay, this is y1, this is y2, this is y3. Okay, so y1 plus 0 y2 plus 0 y3 equals to 9. So y1 is 9. Then second row, 2y1 plus 1 y2 equals to 8. Okay, solve for your y2. Okay, and so on. You will get this y1, y2, y3. Okay, then once you get your y, you put it here. This is your y just now. Okay, ux equals to y. You have your u just now from the decomposition. Now we solve for x. Okay, this one we will start from the last row because zeros are here. So this is x1, x2, x3. So -4 x3 equals to -12. Okay, that's why your x3 is 3. Okay, then second row, x2 is -1. Then from the first row, you get your x1. So this is the final solution. Okay. Okay, I'll try this. Okay, this is in 3 decimal places. So when you decompose 8 into LU, okay, use also 3. Okay, 3 decimal places. The M, okay, the M you can use decimal over decimal values. Okay, your M. Okay, so write out the matrix A first. Okay, write out the matrix A first. Okay, extract the information from the linear system. Okay, you need 2 operations to change this 2 into 0. Okay, so I show you the first operation. The first operation should be a positive value of 2.132 over 1.012 R1 plus R2. Okay, and the second one is negative 3.104 over 1.012 R2 plus R3. Okay. So by right, suppose at this moment you should know how to come up with the operations. And the answer is already given here. Okay, your U supposed to be this. Okay, after you run review, suppose you get this. Right.
Yeah. X3. Okay, let's call 0.4 it's called here.
474.
Three five six.
All right. It is formed. Right? Okay, so we need one more operation. Big 0.473. You get 473. I didn't round off during the calculation. If you just use the value directly, the second row is negative 3.134 divided by 1.012, then multiply directly to 3.104, then plus the same minus 7.013 directly. I don't separate the equation. Yeah, it will affect the little bit. Separate. Zero point zero zero one actually. Okay, so once you have get your U, this is your U. This is matrix U. Okay, then we have to form the L. Okay, form the matrix L. So this is your first pivot. This is your second pivot. And this is your third pivot. So your first column of L will be this 3 divided by 1.012. Okay, so this one divided by 1.012, you get 1. This one should be 1. Okay, this is your L. So okay, 2.132 divided by 1.012, negative 2.107. 3.104 divided by the pivot 3.067. Okay. 0.474. 0.396. Okay, 1197. Okay. So this is your L. Any questions?
Now, I don't think so yeah, you can if I would say would be
Okay, you do not know which column to take. Okay, remember this. First pivot, the one underneath should be the one that you not yet run the raw operation. Okay, so this is your first column for L. Okay, after that, you have to take from another matrix where you have done row reduce these two into 0. Okay, then only you take this is the second pivot. Okay, second pivot. Then make sure underneath is 0. That means you have to look at this one. Okay, after you settle the second one, then only you look for the third one. Okay, so that you know which column to take to form your L.
Numbers are kind of yes. Finance.
This one. Okay, this is your first pivot, right? So this 3 and 3 is divided by this. Yes, all three and 3 is divided by this. So this one divided by itself, you get 1. This one divided by this, you get this. This one divided by this, you get this. Understand? You can start from here. AX equals to B. Okay, then your A will be LU. LUX equals to B. Okay, then give a bracket for the UX. Then we let UX be Y. Okay, let UX be Y. Okay, you have to write this up. So let UX be Y. Hence, LY is B. Then only start. What is the L? What is the B? Stop for Y.
That's the sound.
Okay.
Right there.
So from Ly equals to B, you can use augmented matrix for Ly equals to B.
Right there.
So B is this one. Okay, you can form an augmented matrix. Now that this is y1, y2, and y3. Okay, so either you use matrix form or augmented matrix. Because we just want to solve the linear system. Okay, by forward substitution. Yes, this one you have to use forward. Okay, because the first row, from the first row, you can get y1. Okay, to get y, use forward substitution. Okay, so y1 is 1.984. So 5 இது எடுத்து அதான் Can I use this? Because this is too near to the
Question and இதுதான் தெரியுது மண்டை எப்படி மண்டோட இங்கே இருக்கு
Y. X equals to Y. தெரிஞ்சுட்டா Okay, so let's equals to Y. X equals to Y.
We have to push the
So this one, backward substitution. Okay, backward substitution. This is ux equals to y, so u and y. So this is your x1, x2, x3. Okay, x. Ux equals to y. Okay, so from this last row, x3. So x3 is 1. Okay, so for x2, x2 is also 1.
Awesome. Awesome.
Attendance? Whoever signed your attendance?
That's 0.473 for x3 follow. 0.478 follow x3.
But it's not
Yeah,
4.
for me get 4. But if get 4 means it gets 0.99, not 1. If divide means the down one x2.
4.
But if we solve the x2 one, we got no 1, we got 0.99. Point 395 divided 0.3. But
0.997.
yeah, but actually at the answers can at the slide. There at the slide it actually is 0.473 also.
Yeah.
But if you calculate, we got 0.474. I'm not sure which one is the correct.
Let's The difference is due to the rounding actually.
Yeah.
If you use
But if-
software to compute, you will get this 0.997 actually.
Is that?
Because normally software, it won't separate your calculation. It will induce, I think, more than 10 decimal places. That's why it will be very accurate.
So is it acceptable the answer? 0.997?
997.
Because yeah,
But for us, 4, right?
74.
Yeah, 4.
747.
Di atas kritik.
One, yes, I would accept one as well. Okay, but if we follow strictly, this one is a bit.
Because that one is
For numerical methods, normally we will ask for 4 decimal places. Okay, if you use 4 decimal places, it will be slightly different from this set of answers. Okay. Okay, this one, let me tell you something. This one, if this is 4 decimal places, okay, if you are asked to work out the solution in 4 decimal places, that means what I see will be 3 decimal places for your answers. Okay. So if this is 3 decimal places, that means I will look at 2 decimal places. When I do the marking, what I accept, it will be 2 decimal places. So for this one, this is still acceptable. Not plus minus, the decimal places. Because 4 decimal places, maybe some of you get 9923, some of you get 9924. It is slightly different, but I will look at 3 decimal places. So if you was strictly suppose the 3 decimal places value. Suppose if you follow strictly with 4 decimal places, and if I check for 3 decimal places, suppose all of you get the same 3 decimal places back. Okay, rounding from your decimal places. Okay. Any questions for this one? Any more questions for LU decomposition? This one I just give one exercise. Okay, one hands-on in the class, so you can try tutorial questions. More exercise. Okay, next one. We look at the last one, where we need to complete it by today. Now look at the screen. Okay, look at the screen. Okay, this is the last method, the third one, Gauss Seidel. Okay, to use this, there's one condition. The matrix A, it must be strictly diagonal dominant matrix. Okay, what is strictly diagonal dominant matrix? Okay, dominant, you know what is dominant means? The largest one, right? The dominant. Diagonal, this is the diagonal. Okay, strictly later. Okay, magnitude of diagonal entry. The magnitude, we just look at the magnitude of the diagonal entry. Okay, in a row is larger than the sum of the magnitudes of all the other entries. Okay, meaning that all of these entries, we just look at the magnitude. Okay, magnitude, this one, 3 magnitude values. And this diagonal entry magnitude should be greater than the sum of the rest. Okay, so the sum of these two is 5. Okay, this is positive 2 plus positive 3, which is positive 5, where 6 is greater than 5. And from the second row, okay, this is the diagonal entry. So the magnitude is 9. Okay, you see the modulus? Modulus negative 9 is positive 9, right? So 9 should be greater than 1 plus 4. We just look at the magnitude. Okay, magnitude of this is 1. Magnitude of this is 4. So 1 plus 4 is 5. Okay, so magnitude of this is 9. So 9 is greater than 5. And the last row, this one, the magnitude is 7. So 7 is greater than 3. When you sum up the magnitude of these two is 3. Okay, so when this criteria, okay, are being satisfied, that means this matrix is a strictly diagonal dominant matrix. Okay, now strictly. Strictly means this must be greater than, no equal is allowed. Because strictly, it must be greater than, no equal. So that's why you don't see any equal here. So if you see equal, let's say this is 6, this is 3, this is 3, that means it does not satisfy the criteria. Okay, because it must be strictly, okay, strictly greater than. Okay. Now we look at the floor and also the basic idea of this Gauss Seidel. We will solve the unknown variable. Unknown variable means the x1, x2, x3s. Okay, unknown variables. Okay, we want to solve the unknown variable of a linear system iteratively. Okay, iteratively, that means repeatedly, by using previously computed results as soon as they are available. Okay, this one I will show you on the whiteboard. Okay, I'll show you later. I show you this flow first. Okay, this is a linear system. Okay, this is a linear system where we need to check the matrix A, whether it is strictly diagonal dominant matrix. Okay, if yes, then we proceed to find for the iterative sequence. If no, then we will try to swap the rows, see whether we manage to get a matrix that satisfies this criteria. Okay, if no matter how we swap, we can't get it, that means we can't use this method to solve the linear system. Okay, some of the linear system after you swap, oh yes, you can get the matrix that you want, which is satisfying this criteria. Okay. So if yes, we proceed to find for the iterative sequence. Okay, the iterative sequence is some kind of formula. Formula for x1, x2, and x3. Okay, formula for this x1, x2, and x3 because we need to find for these three values. Okay, initial gas. Okay, we need the initial values will be given. Initial values will be given. Okay, and since we solve this iteratively, that's when we repeat the process. When to stop? This is the stopping criteria. Okay, this is the stopping criteria. We will stop when the value of this norm. Okay, this is known as infinity norm. Okay, infinity norm. When this infinity norm is less than a given small value, this is called epsilon. Okay, this is epsilon. This will be given in the question. So when the infinity norm is less than the epsilon, then we will stop the iteration and give a conclusion. Okay, this is your x1, x2, and x3. Okay, this one I show you this one first. Okay, iterative sequence. Huh? Okay, later I will back to this basic idea. Okay, so let's say this linear system, the matrix A satisfied the criteria. Okay, let's say it satisfied the criteria. Then we have to proceed to find for this formula. Okay, formula. Okay, so how to get this? You see, this is x1. Okay, this is x1. So this x1, okay, we want only this x1 to stay on the left. The rest we bring them to the right. Okay, we want only this x1. From the first row, we want only the x1 to stay on the left. Okay, so we will move these two to the right. So we have b1 minus this, right? Then only divided by a11. Right? Right enough. This one stay on the left, these two bring to the right. So you have b1 minus this. Then the last step will be everything divided by a11. So that's why you have 1 over a11. Okay. Then from the second row, we want this x2 to stay on the left. So this one and this one, we move them to the right first. Then only everything divided by a22. Okay, same goes to x3. From third row, we want this x3 to stay on the left. This term and this term, we move them to the right first. So we get this. Then everything divided by a33. So this is the formulas for x1, x2, x3. Okay. Okay, now I show you the basic idea. What it means by we will use the result as soon as they are available. Okay, I use A. Okay, now look at the whiteboard. You will need to form a table, something like this. This is for iteration, okay, iteration value. Okay, this is for x1, x2, x3, and error. Okay, the errors, that means this one referring to the infinity node. Okay, infinity node. Okay, you will be given initial guess. Okay, initial value. Okay, initial values. Normally, you have 0 or you have 1. Okay, it depends on the values given in the question. Okay, let's say they are all 0. So iteration, it will always start from 0. Okay, iteration always start from 0. So what we need to find is the x1, x2, x3 in the next iteration. So to get this, okay, this one, okay, you refer to this one, okay. This is your x1, x2, x3 formula. To get x1, we need x2 and x3. To get x2, we need x1 and x3. Okay, to get x3, we need x1 and x2. Okay, so back to here. To get x1, we need the values from x2 and 3. So that's mean we use these two values, right? We use these two, you put these two into the formula of x1, you will get this value. Okay, you will get this value. Then when it comes to x2, we need x1 and x3, right? So x3, we take this one, right? x3, we take this one. x1, we will take the latest one. The latest one. So we will use this x1 and x3 to get this. Then to get x3, we will use the latest x1, x2 to get x3. Okay, so same goes to the next. To get this, the latest x2, x3 is this one and this one. So these two, you substitute these two into the x1 formula, you get this. Again, this one, you use the latest x1 and latest x3 to get this. And for x3, you use the latest x1 and latest x2 to get this. Keep repeating until this error values is less than the given epsilon. Okay, so back to this one first. So this is what it means by we will use the value. Okay, if you look at the basic idea, we solve the unknown variables iteratively by using previously computed results as soon as they are available. Once they are available, we will use the latest one. Okay, and next, this one, okay, error. Okay, this error, okay, if you look at this one, on the screen. Okay, if you look at this, this one means we will use the xk minus xk minus 1. Okay, the k values refer to the iteration. Okay, iteration. Okay, that's been the current and the previous iteration. Okay, k is current, k minus 1, it will be previous iteration. So this means max. Max, that means we will choose the largest one. Okay, we will choose the largest one. So from this one, okay, this one modulus of x1 minus x1, x2 minus x2, x3 minus x3, we all just look at the magnitude. Okay, then we choose the largest one to be the error. Okay, this one, I give an example here. Let's say what you obtain here is 1.5. Let's say this is 2.7. Let's say this is negative 0.5. Okay, let's say this is what you get. So there's no error at the first row because error must be computed from the current minus the previous. This is the first. There's no previous row for the first row. Okay, so it will start from here. So we will find the difference between these two. difference between these two, in modulus. So the difference is 1.5, 2.7, 0.5. Which one is the largest one? 2.7, right? 2.7. The largest one, you put it here. Okay, one more. Let's say this is 1.3. This is 2.8, negative 0.1. Let's say. So the difference is
0.2.
0.2. This one 0.1. This one
0.4.
0.4. Okay, we don't take negative. Your error must be all positive value. Remember, your error will always be positive value. Because what we take is just the modulus. This one can normally be used this minus this, then we take the modulus value. Okay, this one minus this, we take the modulus, and this one negative 0.1 minus negative 0.5, then we take the magnitude. Okay, so the largest one, we put it here. And here you will see that this value, it will keep reducing. Reduce, let's say reduce, until, let's say, your epsilon is even at 0.001. Okay, so 0.001, this is still larger than this, so you still need to keep on until, let's say, 0.0001. Okay, so this is less than the given epsilon.
Yeah.
Less than 0.001. So the last one, okay, this x1, x2, x3 is the final solution. Okay, when the stopping criteria is being satisfied, that row gives you the final answer. Okay. Okay, and one more. I want to explain a little bit on this. Why there is k plus 1 and k. Okay, so you see this k plus 1, this is k, this is k, this is k plus 1, this is k, and both are k plus 1. This one, you just need to understand that k is the current iteration. K plus 1 is the next. Okay, but here, this one, k plus 1. X1, k plus 1. If this is k plus 1, k will be this. Right? If this is k, k minus 1 will be this. You get what I mean? If this is k, this is iteration k, then iteration k minus 1 will be this one. If this is k plus 1, iteration k plus 1, then iteration k will be this one. So now we are computing for x1 k plus 1, right? Okay, this one, let's say we want to find for this. This is x1 k plus 1. So if you look at the formula, x2 and x3 from k, that's mean from upper row, from these two. Okay, for x2, this is k plus 1. If this is k plus 1, your x1 from k plus 1, x3 from k. Okay, that is just what it's referring to. Where is your x1, x2, x3 from? Okay, so when you do the calculation, when you form your iterations, this is called an iteration sequence. When you form your iteration sequence, you don't have to write this out, k plus 1 of k. Okay, you don't have to write this out. Just move the terms, okay, and left the x1, x2, x3 on the left, then that is your iteration sequence. Okay, we look at one example. Okay, solve this linear system by using Gauss Seidel. Okay, this one. Okay, this initial gas, you see this 0 in volt. 0 in volt, it means 0, 0, 0 in a vector. This one. Okay, x0. This is iteration. That means iteration 0 of x is 0 vector. Okay, so the first row is 0, 0, 0. And we stop the iteration when the error less than 0.001. Okay, so from here, this one, we will check for the strictly diagonal dominant criteria. So 12 is greater than 4, right? 1 is greater than 12, correct? No, that means this does not satisfy the criteria. So we try to swap. Okay, this one, this is greater than 3. This one, 8 is greater than 2. So we try to swap the second and third row. Okay, we try to swap the second and third row because these 3 are dominant. These 3 are dominant in their rows. Okay, 12 is dominant, 10 is dominant, 8 is dominant. The dominant means the magnitude is greater than the sum of the magnitude. It's not being the largest, not largest, but the magnitude is greater than the sum of the rest of the magnitude. Okay, then after we swap, we get this. Okay, so this is satisfying the criteria. Okay, then we can form the iterative sequence. So we want from this first row, we want this x1 to stay on the left. So this first row, it will give you this. Okay, so 15, this one moves to the right, this one moves to the right. 15 minus 3x2 plus x3. But you don't have to write this k plus 1. Okay, you don't have to write this. I don't want to confuse you with this k and k plus 1. As long as you know where to get the values of x1, x2, x3, that is fine. Okay, then from the second row, we want this x2. So 20 minus x1 minus x3 here. Then everything divided by 8. Then goes to the last one. We want this x3. So 30 minus 2x1 plus x2. And then everything in the bracket divided by 10. So this is your formula. Okay. The name is iterative sequence. Once you form your iterative sequence, construct the table. Okay, construct the table. So this is the table. This is the initial values given. Okay, initial values given from the question. Then we start from the first iteration. So to get this 1.25, how to get this 1.25? X2, okay, this one, to get X1, your X2 is 0, X3 is 0, so you have 15. 15 divided by 12, you get this 1.25. Okay, then to get the X2, we use this formula, X2. Okay, X1 is what you get just now, 1.12. X3 is still 0. Okay, X3 is still 0. So you compute this. Okay, you use this one, 1.25 and 0. You compute, you get this. Okay, and to get X3, use this X1 and X2. Okay, this X1 and X2 here. Then use your calculator to compute for X3. Okay, then find the difference between these two, these two, these two. The largest one, you put it under error. Okay, remember error will be all positive values. Okay, then next find for this. So to get this, you need this two. To get this, you need this two. To get this, you need this two. Then again, this one minus this. This one minus this. This one minus this. Take the magnitude. Which one is the largest one? You put it here. Okay, so you repeat the process until just now the epsilon is 0.001. 0.001. Okay, 0.001, this one. This is still larger than 0.001. So one more iteration. This is less than 0.001. Then you stop the iteration here and give your final answer in the vector form. Okay, so this 1, 2, 3 will be your final answer. Okay. Okay, this is another example. Okay, similar. Iteration. Initial values are all 0. We need to stop the iteration when the error is less than 0.0005. Okay, so from here, check for the strictly diagonal dominant criteria. So if you look at this is dominant. This is dominant. And this is dominant. So the first row should be this. The second row should be this. And the third row should be this. So we just swap. Okay, this is the one. Okay, this is what we want. Then form your iterative sequence. Okay, we want this x1, this x2, and this x3. Yeah, form the table. Okay, when the error is less than 0.0005 just now. Okay, the error. Okay, so 0 is less than 0.0005. That's why we can stop the iteration here. And you give your final answer. Okay. Okay, now we try this. Okay, try this. Okay. Check for the strictly diagonal dominant criteria. Then form your iterative sequence. Okay, so the first row should be the 4x1. Okay, 4x1 minus x2 minus x3 equals 2.
3.
3. And the second row should be
Negative
negative 2.
X1
x1
6
plus 6x2
x3
plus x3 equals to 9. Okay, and the third row is negative x1 plus x2 plus negative x3 equals to negative 6. Okay, so from here, form your iterative sequence. Okay, x1, x2, x3.
X1 equals to 104.
Okay, after you form your iterative sequence, please double check because your calculation is all based on your x1, x2, x3. If the sign is wrong, if you have a sign 4, that's mean 4 wrong. Your figures, all your figures in the table will be 1 wrong. So double check your iterative sequence before you compute for the table.
தூக்கம் தூக்கம் அந்த மாதிரி ஒரு தூக்கம் அப்படின்னு சொல்றாரு. தூக்கம் 6 மணி நேரம் இருப்பேன். Dollar X minus plus X 2 X2 minus plus Nào trong cố sự là cái gì cũng chưa sai thì trong cái sẽ là cũng là cái kia luôn nói nó thì nó thì lại đây tìm không nó nói thì nó có tên là những người đã từng đi những người đã tập đi vào được bạn what người ta còn làm one was seven bread good negative six negative six plus x minus người ta nhìn thấy là Poland bedah, Poland bedah,
Okay, the initial values given from the questions are 0. 0. We start from the first iteration. Okay, so substitute 0, 0. Okay, this one 0, 0 into here, and here you get 3 over 4.
yeah,
Okay, 3 over 4 is 0.75. Okay, so use 4 decimal places. Okay, use 4 decimal places. When the question it doesn't state how many iteration, how many decimal places, then you just stick 4. Okay, 4 is the standard one. Okay, the standard is 4. So use 4. Unless it's stated use 3 or use 5 or use 6, then you have to follow. Okay, but if it doesn't state in the question, use 4 decimal places. Okay, so x2.
1.75.
To get x2, you need x1, x3. So x1 is 0.75. x3 is 0. So what do you get?
1.75.
1.75.
Yeah. Yes.
Okay, then use the latest one, 0.75 and 1.75 to compute for x3.
Error in the data. Này, nào cũng có gà. Tendré que la carta nacional. Él iba a ir.
Okay, what is x3?
-1.
Negative 1. Negative 1. So the error is
1.75.
1.75.
X2 மட்டும் செய்யணும். X1, X3 இல்ல எல்லாம் சேர்ந்து திருப்பி கம்பைன் இந்த ஏரை வந்து அவன் அதான் நான் பார்த்தேன் அவன் ஸ்லைட் அடிச்சிட்டேன். இந்த ஏர்ல வந்து ஒரு நம்பர் கொடுக்குது. இந்த நம்பர்
shows them. Just calculate and put the values into the table.
நீங்க இங்க வாங்க.
So what is the next one?
I think 0.9375.
0.9375.
Yeah. Then, you just show the slide because I want to see the absolute, what
That's the one.
the error until the
So is 0.001.
0.001.
Okay, and so on is 0.001.
Oh, that's not. Point. Yes. 159. ஆனா ஒரு இது இஸ்லாம் பண்ண வச்சுக்கேன் எல்லாம் பிள்ளைகளே சொல்லணும் அங்க அவன் அது படிக்கணும் இல்ல அவ்வளவுதான் அதோட உட்காந்து எழுது
Four places. Four decimal places.
X2, okay, it's two. Yeah. 1, 6, 9,
Okay, X2 is 1.9792, correct?
Yeah. X2, X3, 3 plus 1.979. And then 1.0. 1.933.
Okay, X3 is negative 1.006.
Yeah. So the error is 1.9.
So to get error, use this one minus this, this one minus this one minus this, and find the largest difference.
No. But actually, yeah. Yes, but like, okay, later on, let's say. Yeah, 2.229.
Okay. So when you find for the difference between these two, and these two, the largest one is
0.292.
okay. The one that I write in blue, okay, the one I write in blue is the error, the difference between these two, and these two. Okay, then the third iteration.
One over 7 minus 6 last. It's on the 12.993. Oh, negative. Okay, minus 6 to 7. 0.938. Okay, per unit is minus 0.993. Minus 0.0005. Yeah. 0.058. X3 ulang. X1 udah 0.9 5 greatest in minutes and it's there is one number. That 0 0 0 0 buka putana ba okay betul lagi ida concern ya actually dah reason dong ya 0.9
செல்ஃப் ஆன்சர் கிடைச்சிச்சுடா ஏனிங்க குண்டு வந்து அப்படி
இதோட சின்ன இப்ப வந்து நம்ம இது சேர்ந்து இதோட சொல்றது நம்மளுக்கு வந்து இதோட பொருவ வேல்யூ கிடைக்கிறது கிடைச்சிச்சு இதோட அப்ப ஒன்னும் சொல்லணுமா ஐயோ அதான் ஜோக்கணும் 3 plus 2
This is less than 0.001. That's why you stop here and write the final answer here. One, two, -1.
இல்ல இது மூணு எது புதுசா இருக்கோ அது எதுதான் அந்த புதுசுக்கு வரவா இருக்கு Plus 1 minus
Normally this sub topic normally come out in midterm or quiz. Normally, I'm not sure for this round. Okay, so if there are no more questions, then I will see you next week.
0.001